Hey friends, welcome back to Math Defined. Today we're talking about something you see all the time: polls, surveys, and reviews. But here's the catch: not all data tells the truth. Today's lesson is about figuring out when we can trust the data collected and the conclusions made from it, and when we can't. We're going to be talking about random samples and populations. There's not a lot of computation today, but there is a lot of thinking. I'll be asking you to explain your reasoning, because that's what matters the most here. By the end of this lesson, you will understand how random samples help us make conclusions, not just what a sample is, but why it matters. Let's start with two important words. A population is the entire group you want information about, like all the students in the middle school or all the people who live in a specific state or country. A sample is a part of that population. We usually take samples because studying an entire population isn't always realistic. Let's say we want to know what students at your school think about longer lunch periods. The population is every student at the school. The sample is the group of students we actually ask. The big question is, does this sample fairly represent the population? Well, that depends. We need more information. First, we need to determine whether the sample is a biased sample. A biased sample is a sample that does not represent the population fairly. A biased sample happens when some people have a better chance of being chosen than others. This means the results are leaning one way, and that's a problem. Let's go back to our survey question. Would you like a longer lunch period? If we only ask basketball players about lunch, is that fair? No, that sample ignores students who don't play sports, so the results don't represent the whole school. That's a biased sample. Here's why this matters. If the sample is biased, the conclusion may not be valid. It might sound convincing, but it doesn't reflect the entire population. So even if your math is correct, your conclusion can still be wrong. So what is an unbiased sample? It is a sample where every member of the population has an equal chance of being selected. It doesn't mean that everyone agrees or has the same answers to the survey question. It just means that everyone has an equal chance to be selected. That's the key idea, and what makes the results more trustworthy. Instead of asking just basketball players if they would like a longer lunch period, we can randomly select 56 students from a school roster. This would be much better. By choosing students randomly, we're not favoring one group over another. That means our sample is more likely to represent the entire school population. Once we have an unbiased sample, we can use what we learn to make a conclusion about the population. I'm not saying that it's perfect, but it's reasonable. So if 70% of the students answered yes, they would like a longer lunch period, we can make the conclusion that about 70% of the middle school student population may like a longer lunch period. Because the sample was unbiased, this conclusion makes sense. Notice the word may. We're making an informed estimate, not a guarantee. What if we only surveyed students leaving the cafeteria at lunch? Would this sample be biased or unbiased? It's biased because it only includes students who eat in the cafeteria. Keep in mind, if your sample is biased, then your conclusion is not reliable. But if your sample is unbiased, your conclusion is much stronger. All right, friends, now it's your turn. We've talked about populations, samples, and what makes a sample biased or unbiased. But the real learning happens when you try it. So on the next few slides, I want you to pause the video, think it through, and explain your reasoning. No rushing, no guessing, just good thinking. A survey asked 30 students about their favorite school subject. What is the population? Pause the video and think about this one. Don't rush. Remember, the population is the entire group we want information about. Unpause when you're ready to check. The population is all students at the school. Only 30 students were surveyed. What is the sample? Now think about this. Who actually gave the data? The sample is the 30 students who were surveyed. A teacher surveys only students in honors math classes about homework length. Is this sample biased or unbiased? This sample is biased, but do you know why it is biased? Because it only includes students in honors math classes and does not represent all students in the school. Why might conclusions from this sample not be valid? What could go wrong? Think about how this group of honors math students might feel differently than other students. The conclusion may not be valid because honor students may have different homework expectations than the rest of the student population. A computer randomly selects 40 student ID numbers from the entire school. Is this sample biased or unbiased? Pause and decide, then explain your reasoning. This sample is unbiased. But why? Because every student had an equal chance of being selected. In a random sample, 65% of students say they want longer passing periods. What is a reasonable conclusion about the student population? Careful here, use words like may or about. We could make a reasonable conclusion that about 65% of the student population may want longer passing periods. Remember, we're making an informed estimate about what the student population wants, not a guarantee. A survey about school spirit is given only to students at a pep rally. Is the sample biased or unbiased? The sample is biased, but why? Students at a pep rally are more likely to have strong school spirit, so the sample does not represent all students. Understanding random samples helps you become a smarter thinker. You're going to see surveys, polls, statistics, and percentages everywhere, online, in school, and in real life. When you know how to tell the difference between a biased and an unbiased sample, you don't just accept information, you question it. You ask, who was surveyed? Who wasn't? Is this actually fair? Can I trust the conclusion? This isn't just a math skill, it's a life skill. And the better you understand it now, the stronger your thinking will be later. Thanks for watching, and please take a moment to help support Math Defined. Smash the like, hit subscribe, it's free, and helps you keep up with new lessons. I'll see you soon, and as always, keep math awesome.